Welcome to the notes for the second part of H10-4. These notes will be on summation notation. Okay, so typically this is sometimes taught the day after, but we tried to combine this lesson into one. I wasn't sure if it'd be too long, being that you're learning this stuff at home this year, but we'll see how it goes. So we've included it here, but it's in a separate video in case you needed a break from the other stuff. So summation notation, also called sigma notation, okay, looks like this. This is a shorter way to write, we're finding the sum of a series here, right? And you'll see this weird looking symbol in here. This weird looking symbol that you see is the Greek letter sigma, okay? So that sigma is like the capital S, but in the Greek language there. So you notice when I've been finding the sum, I've been putting the sum of, say, like n number of terms. I've been using a capital S, kind of similar fashion there. They're using that as well. Okay, so this is sigma, and this is why it's also called sigma notation. Now, some other parts to this here. I'm just going to kind of point it out here. You've got a letter here equals a number. So what this letter is, we refer to this as the index. Okay, so we call this the index. That K value is the index. And you will also see it in an expression over here that follows sigma. This is like your nth term expression that you see in like your nth term formula there. This is like the formula for like the nth term, except we're using K, so they have a K in there instead. Now, some of the other characteristics you'll see K equals a number, and then there's a number above sigma as well, right? We've got a 1 down here, and we've got a 5 up here. So this is telling you the term numbers that you're going to be putting together in your series. So we're going to be finding the sum from the first term in the series. So this is where we start. Our starting term number, we'll say. And then this would be like our ending term number, our last term number in the series that we're adding together. Notice I say term number because you'll see here that we have a series written here, -1, +1, +3, +5, +7. The term numbers here, right? This is term number 1, this is term number 2, 3, 4, and 5. Okay, so where those terms actually come from is what we call the argument. Okay, this is the argument, 2k minus 3. So, you know, the 2k minus 3 here is what we call the argument of the summation. It's like your explicit rule. Okay, we find our terms using that expression. So, for instance, this statement that you see up here that I have boxed in red, the way this would read here is we're going to find the sum of the first through the fifth terms of the series formed by the expression 2k minus 3. Okay, and they already found the sum and said the sum was equal to 15. Okay, but that's what this information is telling us. So where do these terms, like how do we know where the -1, 1, 3, 5, and 7 all come from? Well, you could use your T of n or A sub n formulas there to find those, right? If I know that this is the first term, right? The first term is -1. If I do the first term would equal, right? I'm going to take it here. I'm going to use my argument here, 2k minus 3. But instead of putting in my k, I'm putting in 1 in its place. So I have 2 times 1 minus 3, which is going to give me -1. And you see here, -1 is the first term. Okay, then, we'll do a second one here just to make sure we're grasping it here. Our second term is 1. So I'd say my second term, or A sub 2, is equal to 2 times 2, right? That's this 2 right here, minus 3. 2 times 2 is 4, minus 3 is 1. And you see here, right, we've got 1 here is supposed to be our second term, and you see here it is the second term in the series. And then it continues on there, right? A sub 3 equals 3. A sub 4 is equal to 5, and A sub 5 is equal to 7. And they obviously took all those numbers and added them to get that 15 at the end. Okay, so just that's a little bit of terminology there. This may seem really foreign to you, but if you keep after it, you will grasp it there at some point. Just make sure you're reaching out if you have questions. We'll go through a couple examples to hopefully help it make sense to you here. So let's look at number 7 here first. Number 7 says, find the sum of each arithmetic series described below. Okay, and then this, for practice, you want to make sure you're looking at problems 3, 4, and 5 from the homework worksheet. Okay, so we put some specific problems that relate to this in there so that you can practice. So letter A says, we're going to find the sum from the first term to the 10th term of the series that's generated using this statement here. Okay, so some of the things we know here, we know the number of terms. If you're going from the first term to the 10th term, there's going to be 10 terms. Okay, now these numbers sometimes will be different here, but if I had from the first term to the 10th term, I know that there are 10 terms. Okay, so then I also need to know, if I'm doing the sum of a series, I need to know what a sub 1 is going to be, and I need to know what a sub 10 is going to be, right? My first term and my last term. So the first term, we'll find it there by plugging in 1 into that statement here. So I have negative 5 plus 13 times 1, right? So this 1 matches this. Now what we end up with here, 13 plus negative 5 is going to be positive 8. And that means that is our first term. Our 10th term, we're going to take it, we're going to plug in our 10. We have negative 5 plus 13 times 10. 13 times 10 is 130, minus 5 is 125. So our series would go something like negative 5 plus, something, plus dot, 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 all the way until we got to the end. That last term that we're dealing with is 125. So let's just find our sum then, right? So we're going to say the sum of the first 10 terms is going to equal, and we'll say our first term is 8 plus, looks like what, 125 is going to equal, oops, I'm sorry, I forgot, oof, that was close, right? Don't want to screw it up here, times half our number of terms, right? We have 10 terms divided by 2. Now we have 133 times 5, and when we do that there, that should be what, 500 plus 150 plus 15, so that would be 665 would be the sum of the first 10 terms of that series. So we'll say that equals 665. That is our answer. Okay, now if you want to pause the video and try this one on your own, please feel free to do that there. I'm going to go ahead and solve it here just in case somebody has a question about it at all. So we're trying to find the sum from the first term to the 30th term of the series that's generated using this rule here. So again, with this one, since I know it starts with 1 and it goes to the 30th term, I know that there are 30 terms. Okay, so we need to know the first term and we need to know the 30th term. So we'll say a sub 1 will equal 10 minus 5 times 1, which would be 5. And then we'd have a sub 30 would equal 10 minus 5 times 30. Well, 5 times 30 is 150, and then we have 10 less than that, would be a negative 140 there. Okay, so then we're going to take it, we're going to use that information. We're going to say the sum of the first 30 terms is going to equal, we've got 5 plus negative 140, and then we're going to multiply that by half the number of terms, so 30 divided by 2. 5 plus negative 140 is negative 135, and then we're going to multiply that by, what's 30 divided by 2 is 15. And I'm not really feeling the mental math tonight, so let's just go ahead and grab a calculator out and do that. Let's see, we've got, we said negative 135 times 15. We get negative 2,025. And that is the answer we could write up here with our summation notation. This equals negative 2,025. If you have questions about that, please make sure you're reaching out. Again, remember this is the first term number, 30th term number there. You got to plug each of those in to find those values, figure out there how many terms you've got, and then plug it in. All right, hopefully that helps here. I'll actually go right on into the next problem.